Hi there. We're going to go over some of the basics now on units of measurement. And this is probably pretty simple for most of you. And if you know the metric system at all, this should be a no-brainer. But for some of you who maybe aren't familiar with the metric system, don't allow these terms to surprise you. They're actually really easy. In the metric system, the thing that's so great is everything is divided by or multiplied by tens and hundreds. So it's just a matter of moving the decimal place to find out what the smaller unit is or the larger unit. Let's start with the unit of measurement. And we're only going to be dealing here with the items that we find in amateur radio. You could compare this to all sorts of units of measurement, or to your grams and kilograms and milligrams and things like that. You could apply this in the kitchen if you wanted. But we're going to talk ham radio. So let's start with this one. Well, here I'm looking at meters. And in amateur radio, we really only use about 2 units of measurement as far as wavelength goes. And so we have meters. The smaller unit that we use is centimeters. I'll just put the prefix centimeters, okay? And for those of you, just so you can put this all in relation, the larger unit would be kilometers. Like what many of you on your speedometer, we even have a little kilometer dial there. All right, so what do we know? We know that 100 centimeters equals 1 meter. And that's really all you need to know. Well, that is how many zeros. If you have 200 centimeters, how do you find out how many meters? Well, just move the decimal place 2 places. 2 meters is the same as 200 centimeters. So because it's 100, you always just move the decimal place 2 places. What if you have 0.02 meters? How many centimeters is that? Well, we move the decimal place 2 places, and it is going to be 2 centimeters. I hope that makes sense. It's pretty simple. We just move the decimal place around from the 100 to the meters. The centimeters is 100 centimeters in 1 meter. And the way this relates to amateur radio is going to be, you have the 440 band, or 440 megahertz, and we want to know what the frequency is. Well, we're going to take 300, remember. Let me go ahead and do this right here. We'll take 300 divided by 440 megahertz. Remember, that equals wavelength. So 300, and we know it's going to be a decimal because the bottom number is bigger than the top, 0.68. Just make sure I hit all the right buttons here. Yep, 0.68. So that's saying the wavelength equals 0.68, and remember, wavelength is always what? Meters. So 0.68 meters. Well, how do we find out? What's a better way to say that? Well, probably would be, instead of 0.68 meters, to do it in a smaller unit of measurement. So let's go 2 places over, and that's going to give us wavelength equals 68 centimeters. Well, there's not a 68 centimeter band. The band that's closest, though, is the 70 centimeter band. So you just learn the 2 meter band, the 70 centimeter band. There's some other ones, the 1 1/4 or the 220 megahertz band. You'll learn all those in your book, but this is how it relates mathematically. So you've got your wavelength. We figured it out. Megahertz, we found out that was a decimal, and we decided to move it to centimeters. That's why you need to know this, so you can show it in centimeters, or vice versa. You could say, if I need to find out what the megahertz is on this, well, it has to be 300 divided by megahertz. So it can't be 300 divided by 70. It has to be 300 divided by 0.7. And that's going to tell me 300 divided by 0.7 equals 428. 428 megahertz. So there you go. Okay, I hope that helps clear that up. Now, let's just look a little bit at how the hertzes relate to each other. With the hertzes, we have a few more options here. So we have hertz, which is the smallest unit. Remember, that's how many cycles per second. Then we have kilohertz. And there are 1,000 kilos of the individual unit. 1,000. So 1,000 hertz in here. And then we have megahertz. And there are 1,000,000 hertz in a mega. So you take 1,000,000 and you subtract, so you got 1,000 here. Because 1,000 times 1,000 is 1,000,000. So that's how all that works. 1,000 kilos in a mega, 1,000 hertz in a kilo, and 1,000,000 hertz in a mega. We'll skip gigahertz for now, but I wanted to show that there just so you could see how that works. Again, remember your equation here is frequency equals 300 over wavelength, or wavelength equals 300 over frequency. And remember, frequency has to be megahertz and wavelength has to be meters. So if your number is in kilohertz, so for instance, if we go down on the band here, and we are, if we go quite a ways down here, we can go to what is, 1.9 megahertz. Well, that commonly would be referred to, or actually, let's go even farther down to what would be your normal AM dial, which is going to be, I don't know if I can get there fast enough to finish this video, but we're going to, yeah, here we go. We're going to go down to like, well, let's say 1440. That's on your AM dial. That's 1440 kilohertz. 1440 kilohertz. Well, this doesn't work for this equation. So if you want to figure out what the wavelength is, you have to convert 1440 kilohertz to megahertz. How do we do that? 1,000, 3 decimal places. Boom, boom, boom. 1.440 megahertz. 1.440 megahertz. So now we're going to go 300 divided by 1.440 megahertz equals 208. 208 meters. So when you're picking up that 1440 kilohertz AM signal, one cycle is 208 meters long. One wavelength is 208 meters long. Hope that helps.